The construction of the Bismarck began with one of the most symbolic steps in naval engineering, the laying of the keel. Inside the enormous Blohm & Voss shipyard in Hamburg, a vast dry dock was prepared to support thousands of tons of future steel. Massive crane gantries moved into position, lowering the first plates that formed the spine of what would become one of the largest and most powerful warships ever built. From this foundational beam, workers began assembling a forest of steel frames, towering ribs that gave the battleship its shape and strength. Each rib was forged from thick, high-tensile steel, bent precisely to match the curvature of the hull. As they were lifted into place, teams of welders and riveters connected them with deafening showers of sparks. The skeletal outline stretched longer each week until the structure resembled the backbone of a metallic sea creature rising from the dock floor. The hull framework had to withstand not only the weight of armor many inches thick, but also the colossal stresses produced by 15-inch guns and engines capable of pushing the ship past 30 knots. The shipyard worked day and night, with hundreds of workers climbing scaffolds, adjusting plates, inspecting joints, and reinforcing critical load points. Every part of this early structure was calculated to millimeter precision. Any weakness here could later compromise the entire ship. As winter rain echoed across the steel plates and fog rolled through the shipyard, the skeleton of the Bismarck continued to grow, setting the stage for the armored giant that would soon take shape above it. The next stage of the Bismarck's construction involved transforming its skeletal frame into a heavily fortified war machine. Workers began installing the ship's armor, some of the thickest ever fitted to a battleship. Giant steel plates, many weighing several tons, were transported on rail carts and lifted by towering cranes. Before installation, the plates were heated and curved to match the hull's contour, a process requiring enormous hydraulic presses and precision engineering. These armor plates formed the ship's main defensive belt, designed to protect critical areas against enemy shellfire and torpedoes. Much of the Bismarck's legendary toughness came from this phase, multiple layers of hardened steel, arranged in angles that increased resistance to penetration. Inside the hull, workers constructed watertight bulkheads that divided the ship into hundreds of compartments. This internal architecture was a crucial survival feature. Even if one section flooded, the ship could remain afloat and operational. The torpedo defense system also began to take shape. Engineers installed inner wells, longitudinal bulkheads, and layered void spaces designed to absorb explosive energy. Machinery rooms, ammunition magazines, and fuel tanks were positioned deep within the armored citadel, ensuring maximum protection. Welding crews moved non-stop along the hull, sealing joints and reinforcing critical seams. Gradually, the Bismarck evolved from a steel skeleton into a fortress, hinting at the destructive power and resilience that would later make it one of the most feared warships of the Second World War. As the hull gained its armor and internal compartments, the shipyard progressed to constructing the expansive main deck and superstructures. The deck plates were enormous, each one lowered by cranes with precision as workers guided them into place. Once aligned, welding teams joined the plates into a seamless armored platform. Beneath the deck, the labyrinth of corridors, crew quarters, workshops, and storage rooms continued to expand. Every meter of space was accounted for, designed to support a crew of over 2,000 men. Above the deck, the iconic superstructures began to rise. Prefabricated sections of the forward tower, radar platforms, and range-finding stations were lifted and fitted into place. These towering structures would eventually hold observation posts, fire control equipment, communications arrays, and command rooms. Deep within the ship, electricians installed miles of cabling, while engineers fitted ventilation, piping, and early electronic systems. The Bismarck's inner layers became increasingly complex as builders created dedicated spaces for navigation, coordination, and combat management. Workshops, medical bays, kitchens, ammunition elevators, and living quarters gradually formed an intricate internal city. The shipyard echoed with the clanging of tools and the hum of heavy machinery as the massive warship grew taller and stronger. With each new addition, the Bismarck transitioned from a steel shell into a sophisticated naval command center capable of coordinating devastating firepower on the open sea. The Bismarck's armor was engineered to withstand the heaviest naval artillery of its time, and constructing this protection system demanded precision on a monumental scale. Massive Krupp-cemented steel plates, some weighing over 15 tons, arrived from specialized foundries and were carefully positioned along the hull using giant overhead cranes. Workers aligned each curved plate with millimetric accuracy before welding teams permanently fused them into the ship's belt armor, forming a continuous barrier designed to deflect incoming shells and absorb devastating impacts. Inside the hull, additional defensive layers took shape. A complex system of torpedo bulkheads lined the inner walls, forming multiple sealed compartments intended to localize flooding in case of underwater explosions. Above them, armored decks composed of thick steel slabs were installed section by section, creating a protective ceiling to shield vital machinery, ammunition stores, and the command center from plunging fire. As the structure expanded, technicians inspected every weld, ensuring that not a single weakness remained. Riveters reinforced secondary plates along internal frames, while engineers tested the alignment of bulkheads meant to channel blast energy away from critical systems. By the time this phase ended, the Bismarck had become one of the most heavily armored warships ever built, its defensive architecture a blend of brute strength, advanced metallurgy, and meticulous German engineering. Arming the Bismarck transformed the ship from a steel titan into a fully capable instrument of naval warfare. The process began with the installation of the massive 380mm twin turrets, each an armored fortress weighing over 1,000 tons. Cranes carefully lowered the turret bases into their reinforced barbettes, where engineers connected power cables, rotation mechanisms, and hydraulic loading systems hidden deep within the ship's interior. Next came the secondary armament. Workers mounted the powerful 150mm guns along the sides of the hull, giving the vessel the ability to engage both surface targets and smaller escort ships. Below each turret, magazines, shell elevators, and blast-proof handling rooms were aligned and tested to ensure continuous ammunition flow during combat. Across the superstructure, dozens of anti-aircraft guns were installed, from rapid-firing 20mm cannons to dual-purpose 105mm batteries. Technicians calibrated elevation motors, recoil dampers, and targeting optics, preparing the ship to defend itself against enemy aircraft. No weapon system, however, was complete without advanced fire control technology. Crews mounted optical rangefinders, rotating directors, and complex mechanical computers that calculated firing angles using real-time data. These systems were interconnected through miles of wiring and pneumatic lines stretching throughout the vessel. When the final checks were complete, the Bismarck stood bristling with firepower, its arsenal among the most formidable ever placed on a warship of its era. With the major construction phases complete, the Bismarck entered its final fit-out, a stage where thousands of components transformed the ship from a steel framework into a fully operational battleship. Crews installed communication antennas, radar arrays, signal lamps, and navigation systems across the towering superstructure. Lifeboats, cranes, catapults, and aircraft handling equipment were secured to the deck, while interior teams furnished crew quarters, command rooms, infirmaries, kitchens, and electrical stations. Engineers ran miles of wiring through the compartments, connecting lighting systems, power grids, phone lines, and emergency circuits. Below deck, final adjustments were made to the propulsion system, oil heating units, steam generators, and auxiliary pumps. Every valve, pipe, and cable was inspected repeatedly to ensure reliability under combat conditions. Once the ship was declared structurally complete, the Bismarck sailed for sea trials. Out in open waters, the engines were pushed to maximum output, bringing the ship to speeds exceeding 30 knots. The rudders were tested at sharp angles, verifying the vessel's ability to maneuver despite its immense mass. Weapons crews rotated turrets, elevated guns, and ran loading drills using dummy shells. Radar operators checked their equipment's tracking accuracy, while officers simulated combat procedures from the bridge. By the end of these trials, the Bismarck stood ready for war, an engineering masterpiece built with precision, power, and the intention of dominating the North Atlantic.